Hi everyone. Today we're going to be looking at the Click PLC Easy Transfer Line Programming. Now, EasyPLC Software Suite is a complete PLC, HMI, and machine simulator package software. This PLC learning package includes a machine simulator, or MS, and this virtual 3D world with real-time graphics and physical properties can communicate to several different programmable logic controllers, or PLCs. We will be developing a Click PLC program for a transfer line, and this is just one of the pre-built machines in the simulators to learn PLC programming. We will be developing the ladder logic, connect via Modbus RTU, and test our program. This involves using the 5 steps to program development. So let's get started. Detailed information contained in the video can be found at accautomation.ca. The link has been put in the description below. If you have not watched the other videos yet, there'll be links in the description below that will start you at video 1. There'll be links to the rest of the videos in this series as well. So the machine simulator, or MS, is in the EasyPLC Software Suite, and it helps you development of your PLC control system. This 3D world will allow you to develop your control program and test prior to using it on the physical world. There are several different machine builds that you can connect to and learn to program easily. We will be using the Easy Transfer line in the machine simulator connected to a Click PLC. So when we're looking at development, we will apply the 5 steps to the Easy Transfer line in the machine simulator. And developing the PLC program is a process that can be clearly defined, and the 5 steps along with some practical examples have been demonstrated in a few of the posts, and that is in a link connected below that will bring you back to the website that will show you all those links. So the first step in our development is defining the task. So this is step number 1. Now the machine simulator has a demo mode for the built-in machines. So let's just start this. And you'll see my easy transfer line. And what the demo mode will help you is to see what has to be done. And there is a written version of the sequence on the left-hand side of the machine right here. And so use the photo cell, digital input 1 to detect high boxes, and send it to the second conveyor using the pneumatics pusher, digital output 1. Conveyors are actuated with digital output 1. Optionally, you can use the control panel with the start, digital input 2, and stop, digital input 3, and emergency digital input 3 buttons to activate, start, and stop the system. So in this case here, we're going to use 4 digital outputs and 5 digital inputs. So let's just take a look at the demo just so that we understand the whole process that we're trying to develop here. When we start the demo, you can see at the bottom here it's saying demo mode, and we can actually view the I/O, and we can hit the start button. You see it's lit right now. And now the conveyor belt is now running, and it will produce boxes. This sensor here will sense if the box is high, and if it is, it activates this pusher to push it onto this other conveyor belt here. We can then hit the stop button to stop the process. And you see if the box is actually low, it'll continue going along and just go off. So let's start that again. And we'll just wait for a high box to come and get that pushed off so we can see that actual operation. And in demo mode, we also have a time lapse that allow us to speed up the process. We can apply, and you can see now it's doing a little faster. We can then slow that down, and we go down right to 10 times slower. And so once this sees the box, it'll hit this and put it right on the conveyor belt. There we go, it pushes it out. So that is the process that we're trying to accomplish here. And we'll just turn it back to normal so you can see the normal speed and operation. Hitting the E-stop button actually stops the conveyor, stops the lights, and both lights are off. We reactivate it, turns back on that light. So that's a very good indication of exactly what we're trying to accomplish with this task. So let's just exit back out of this again to the main screen. And we will go back into the start. And this time we will go to the start of the Easy Transfer line. And right now we're saying that there's no PLC connected. So the next step is to find the inputs and outputs that we need. Now remember that our information said that we need the amount of inputs and outputs that we need for this sequence to happen. So, and it requires 4 digital outputs and 5 digital inputs for an easy transfer line. All right. So what we can do now is look at the digital inputs and outputs. As you saw, we can see that what's happening there in our demo mode. And the Click, or the machine simulator, will be communicating to our Click PLC. And communication will be done through Modbus. Now using the Click software, we can actually call up our address picker. And under our address picker, we can choose, make it a little wider, use display Modbus address. And we will be using X101 for our inputs. So this is Modbus address 100033. And that's where our inputs will start. You can see we have 5 inputs: emergency stop button, pneumatic pusher, extend. We have the photo cell, we have the start button on, start button off, and we have the emergency button on. So we have those 5 inputs coming in, and that's our Modbus address. On our output side, we use output Y101, and we have 4 of those. We have a conveyor 3 reverse, pneumatic pusher advanced, we have the start button light and the stop button light. So that is our addresses that we will be using. So we'll just say okay for that. And now what we'll do is, once we've defined what we need to do in that program, then what we do is we can develop a logical sequence of operation for our easy transfer line. Now this is done through a flowchart or a sequence table. It's used to fully understand the process that needs to be controlled. And it must answer all the different questions, like what happens when electrical power or the pneumatic air is lost, what happens when inputs and output devices fail, and do we need redundancy, etc. But it allows you as a programmer to make sure that you fully understand exactly what has to happen every single step along the way and from sequence to sequence. So I have an example of a sequence table, and we'll just call that up. And here's an example of sequence tables. We have our inputs here: emergency stop buttons, the stop, start, photo cell, and the pneumatic pusher. And you can see at step number 0, we have all those off. So all the inputs are off. That means the outputs, while it's in run mode, is going to be the start button light is on. So you see here when we hit the start button, and the rest are off, then we have the stop button light is going to be on, and we're going to have the conveyor belt on. Then when we have a photo cell signal come in, right, and we don't really care what the start button is doing, then what we want to do is we want to still have the start or the stop button light on. We want to do a pneumatic pusher, and we want to still have the conveyor belt on. And then when the pneumatic pusher goes to the advanced position or it's out, and we don't care what the photo cell signal or the start battery is, that's what the X means, then what we'll do is, again, stop still on, and we still have the conveyor on, and we turn off the pneumatic pusher. Next, then we have them all off now, and we have our start belt or our stop light still on, and we have our conveyor belt still on. Then we have a stop button. Then we turn our start button light turns on, and our conveyor goes off, and we go back to the top again. So basically, that is the way in which our cycle has to happen. And then we have another one here that says, well, if we have emergency stop input, then all the outputs turn off. So that is our sequence of operation. And it's very important to this is probably where you're going to spend a lot of your time trying to develop and have questions to make sure that you fully understand exactly what has to happen. So next what we do is we will develop our PLC program. So we call up our software, and here we then start writing our code based on our flowchart or our sequence table. And so we see that if we have the start button on and not the stop button and not the emergency stop, then we can set our conveyor 3 to start running. If we have the stop mode or stop button, or we have the emergency button on, then we automatically reset this conveyor belt. So remember this, the PLC scans all the time. So that controls our conveyor. Next, what we'll do is we'll take a look at the operation of our start-stop lights. And when we have the conveyor belt on, then we have our stop button light that's going to be on. And when we don't have our conveyor belt and we don't have our emergency stop button, then our start button will be on. And then finally what we do is we have our photo cell with our pneumatic pusher. And so when the conveyor belt is on and our photo cell comes on, then we set our pneumatic pusher. And our pneumatic pusher advances until it goes to the advanced position as an input, and then it resets that pneumatic pusher. So it's only one operation. As soon as we see a signal, it sends it out. Once it's extended all the way, it comes back in again. So that is our program. And so now once we have the program and everything looks okay, then what we can do is we can actually then test our program. So let's go back to our machine simulator. And the first thing we will do is connect to this controller from our PLC. And when we look at the actual PLC itself, like I said, we're going to be using the Click Plus PLC. So here is the actual PLC. And you can see here that I have my Ethernet port, and then I have my RS-45, which we will communicate Modbus back into our machine simulator. And we're going through a USB to RS-45 adapter here. And again, links for this adapter and how to install it are located on our website at accautomation.ca. And again, links are described in the blog post for this video. So now let's, first of all, let's call up and let's communicate through that unit. So let's go to IO drivers, and our device driver name will be Modbus. And what we'll do is we'll configure that port, and it's going to be a serial. Now it's RS-232, but it just represents the serial port itself. We're actually going, the serial port represents the 485. Our serial port configuration is COM5 9600 891, which must be the same as what our Click PLC program is. So if we look up the Click PLC, and we'll look up the system configuration, you will see that if I look at my port selection, port number 3, Modbus node address 1, 9600 none 18, which is the same as what we have in our machine simulator. We could also look on port number 1, and we can also use Modbus TCP if we wanted to. Currently right now, we're going to use the software to communicate through port number 1, or Ethernet, and then we're going to use machine simulator to go through port number 3, which is our Modbus RTU RS-45 serial. So we'll just cancel out that. So that's all set up there. And then we have our start address. So these are the digital inputs to the to our machine simulator. So the digital inputs would be the outputs of the PLC, and then we have digital outputs would be the inputs from the PLC. So our Modbus address actually starts one less than where we wanted to start from. So our starting address for our inputs would be 8224, and we want 4 of them, and our outputs will be 32, and we want 5 of them. Now once we say OK, then it brings back these PLC inputs and PLC outputs. And you can see driver inputs, driver outputs were just the opposite. Then what we can do is manually assign to the inputs and manually assign the outputs, or we can just hit driver, automatic assign, and you can see how they just fill in for the inputs and outputs. And then when we go to exit, we can start driver and exit. So now we have the driver connected, and we can now view our I/O here. And if we go back to our Click programming software, we can call up the data view. And on our data view, we have all of the inputs and outputs listed. And what we can do is just what they call ring out the I/O. So troubleshoot and make sure that we have everything mapped correctly. So what we will do is we will operate the actual inputs that we have. So here's my start input, and you can see my start input then goes on as well. That's at X103. Our stop, X104. And then we have our stop, emergency stop. You can see that's on. So that seems to be working well. We can also take a look at our photo cell. We can check it out, but everything else looks good. We can actually turn on our conveyor. And our conveyors now is running. Turn that off. Our pusher, you can see that goes out. We can turn that off. Our start light and our stop light, they both are on, so that's good. So we have everything connected correctly. So what we actually can do now is we can go into our software, Click software, and what we will do is we will actually now start that software. So right now the program's in stop mode to ring out our I/O. We'll start. And then when we start, we can actually look at our status, and we can actually monitor what our PLC program is doing with this easy transfer line. So you can see here now everything is, we have a green light on. If we hit the stop button, okay, everything goes off. Reset it, and now we can't start. So now we're starting our program, and we're actually testing it and seeing how everything works. Once again, we have our time lapse here that we can actually slow it down or speed that up. And we'll just apply normal. And there we go. There's our pusher. We can slow that down so we can watch that a little slower. And then we can test it by entering a few things. We can try our emergency stop as soon as it extends. And you'll see that once we did it, everything now stops. We can then reset it, start again, and it picks up exactly where it left off. And again, once we are on this, we can actually move things around so we can see, we can trick it into thinking there's something there as well. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you'd like a 10% discount on this software package, then please include ACC Automation in the comment section when you order. And this software package is very reasonably priced. It's $75 for a single computer install, or $100 US for different computers, which you'll get a USB stick to do that. So if you want more information about us, or you want our free ebooks on numbering systems or bus data logging, please click on the link in the description below to get it. Now, a new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.